So let's now look at limits of vector function. As you'll recall, vector functions may be written this way, where f of t is a function of one variable, the variable t, and that gives us the x component, and likewise for g and h. Now, the limit of a vector function, it's going to be some vector that as t approaches a, we approach L. Okay? And how do you find that? Well, we have here that the limit as t approaches a of r is going to be the limit as t approaches a of this vector function. And now what you could do is basically take this limit inside the vector function, and so you return back to the calculus 1 concept of the of a limit, where now you're just looking at the limit of a function of a single variable t in 3 different components. So if the limit of f of t in the calc 1 sense is just L1, and the limit of g of t is L2, and the limit of h of t is L3, well, the limit of the vector function r as t approaches a will be L1, L2, L3. In other words, you can say that for decently behaved vector functions, which is all we'll be dealing with, you can move the limit inside the vector. Okay, so you could move the limit into all of the different components, and that's how you will calculate the limits of a vector function. So let's do just that. Consider this a vector function similar to what we've seen before, where the x and y make a sort of circular path, but the z component actually decreases as t increases. It's going e to the minus t. It could also be written this way. Let's find its limit as t goes to 2. Okay, the limit of this vector function as t goes to 2 will be this limit here. But as you'll recall, we could just move the limit into each component. And now we're just dealing with a calc 1 problem when we move the limit into each component. And we could just plug in, for t, we could plug in 2. And that's where we're getting this. And for the sine of pi t, that's where we're getting 2 pi. You just plug in 2. Just as you would if you only saw one component of this in calc 1, you know. And likewise, the limit of as t goes to 2 of e to the minus t is e to the minus 2. And so you get this vector, which also may be written this way, and that is the limit of our vector function as t goes to 2. Now, what about the limit as t goes to infinity? Well, we're going to do the same trick of commuting the limits into the components, but we're going to run into a bit of a problem. Here, we have no issue. The limit as t goes to infinity of e to the minus t is just 0. But sine and cosine of pi t, these don't have a limit. This just keeps oscillating. Sine and cosine keep oscillating. So the limit in the components of x and y do not exist. And if even one component fails to exist, so if the limit in one of the components fails to exist, then the vector function does not have a limit. So if one component does not exist, then the whole vector function will not have a limit. And so the limit as t goes to infinity of r of t does not exist. It's failed due to the x and y component failing. And I should note that this here is a typo, so that extra limit should not have been there. So let's take a look at how this vector function looks. This cosine pi t, sine pi t in the y component, and e to the minus t. So we have our, as we increase t, we move along this trajectory, okay? And at t equals 2, that vector that you see there now is the limit of our vector function when t approaches 2. Well, what about as t goes to infinity? As t goes to infinity, you're going to keep oscillating around and around and around. you get closer and closer to z equals 0, but you never quite reach it. But still, the z component is okay. We're getting closer and closer to 0. But are we getting closer and closer to any type of y value? No, this thing will just keep making circles. The closer we get to the xy plane, the more and more circles it makes, and it never really settles down on any one vector, such as the case when we are taking the limit as t equals 2. When we take the limit as t equals 2, we just stop at that vector there. Increase it, it'll just keep going in circles, getting ever closer to the xy plane, but still oscillating.